One way of finding the integral of a function is using a Riemann sum, which calculates areas of rectangles and adds them together. There actually is a more accurate way of finding the area under a figure, and it's using the trapezoidal rule. At the end of this lesson, you'll be able to use the trapezoidal rule to evaluate a definite integral. Okay, so we're going to start out. We are going to find the area under this curve using 4 trapezoids. Okay, and actually we would be finding, if I was setting up an integral, would be the integral from 0 to 4 of whatever our function happened to be. So anyway, we're going to, instead of using rectangles like a Riemann sum, we're going to use trapezoids. So what I'm going to do is start at 0, I'm going to put a point there, and then I'll put a point at 1. I'm going to connect those two, and then notice I turned that into a trapezoid, and we'll call that trapezoid A. And then I already have a point at 1, I'll put a point at 2, and then I'll connect those two. And there's my second trapezoid, we'll call B. And then for my next one, put points at 2 and 3, connect those 2 points, and we'll call that rectangle C, or trapezoid C. And then we'll connect the last 2, and notice then we'll have a trapezoid D. Notice how much nicer those fit inside of the figure. There is not much room left over, so it should give us a more accurate answer than when we use rectangles. So first of all, area of a trapezoid, you need to remember the area of a trapezoid is 1/2 height times the sum of the bases. Okay, so when I'm doing this first one, notice that they're trapezoids that are turned on their side, so actually all of these horizontal places, those are actually the height. So when we go to find trapezoid A, we're going to do 1/2 times the height. The height of this one is going to be 1. And then we actually can't finish this because I didn't tell you anything. So we basically are going to whatever base 1 plus base 2 ends up being is what we're going to do. And we will continue to do, you know what, I think I'm just going to call this base 1, base 2, base 3, base 4, and base 5. So we'll just make up something up. And so that would be the area of the first trapezoid. The second one is going to be 1/2. Again, it goes from 1 to 2, so the height is 1. This time my 2 bases are B2 and B3. Okay, for C, it's 1/2. The height is still 1. And then the 2 bases that are used in this C trapezoid are B3 and B4. And then for D, we would use 1/2. The height is still 1. The bases that are used are B4 and B5. Okay, so, and then we would just, when we get those answers, we would actually add those all together. And that would be the area under the curve. One thing that I do want you to notice on this one, first of all, they all have a 1/2 and a height. And if I rewrote this, we'd have 1/2 the height, and we could take that out front because they all have 1/2 and they all have the height, or they all have the 1. And then from here, also please notice that if I was going to add all these things up inside, I have one of the B1s, and then notice I have 2 B2s because that base is used twice, and I have 2 B3s, and I have 2 B4s, and I just have 1 B5. So notice all of the inside numbers are actually used twice. Those bases are used twice. What this is going to lead us to is the trapezoidal rule. And here we go. The trapezoidal rule for approximating an area under a curve, the integral, is given by this formula. Please notice in this formula, we are going to calculate the first one would be the end region, and notice this last one is the other end region, and notice each one inside gets multiplied by 2, and hopefully you can see why that was, because when we did the other example, those bases were used 2 times. One thing that I am going to do differently, this is the fancy way of writing the trapezoidal rule. I do this a little bit differently. I actually like to use the formula for the area of a trapezoid. So instead of doing this, I actually like to use 1/2 height. I find that a little bit easier, and as we do the examples, hopefully you will too. All right, let's take a look at the first one. It says to use the trapezoidal rule to approximate the area under the curve from 0 to pi over 2 of cosine x dx for n equals 4. So this is the number of trapezoids we are going to use. Okay, so we could draw it if we want, but I am not going to. What we are going to be doing on this one, the first thing that I like to do is the exact same thing that I did with my Riemann sum. I need to get my intervals. This is going to go from 0 to pi over 2. And so to figure out what I need to go by, pi over 2 minus 0 is pi over 2, and I need to section it into 4 sections. So pi over 2 divided by 4 is the same thing as pi over 2 times 1/4, which is pi over 8. So I am going to go by pi over 8s. So 1 pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8, which is pi over 2. You could simplify the 2 pi over 8 if you want to, but I'm just not going to. Okay, so what we're going to do when we go to use the trapezoidal rule, first of all, trapezoidal rule, we're going to have 1/2 times the height. Well, you'll notice each one of these, the height of them is going to be pi over 8. And then we're going to do f of, well, actually, I'll write it like this instead. We'll have cosine of 0 plus 2 cosine of pi over 8 plus 2 cosine 2 pi over 8 plus 2 cosine 3 pi over 8 plus cosine of pi over 2. Okay, a couple things I want you to notice. First of all the inside numbers were multiplied by 2. The other one, to get the values, we actually have to plug the x values into this formula. Okay, once we do that using our calculator, we should end up getting 0.987 as an answer. Okay, next example. A table of values for a continuous function f is shown below. If 4 equal subintervals of 0 to 2 are used, what is the trapezoidal approximation of the integral from 0 to 2? So again, 4 equal subintervals. So again, what I like to do first is I know that I need to get from 0 to 2. So I make my chart going from 0 to 2. I need 4 intervals. So the distance between those two is 2. I need to break it up into 4 parts. So each part is going to be 1/2. So 0, 0.5, 1, 1.5, and 2. So from here, now what I can do is when I use the trapezoidal rule, it's going to be 1/2 times the height. Well, the height of each one of those is going to be 0.5. And then from here, we can actually calculate f of 0 plus, and I'm just taking them right from my chart, it's going to be 2f of 0.5 plus 2f of 1 plus 2f of 1.5 plus f of 2. Please notice when I did that, I was not looking at the table at all. I was strictly referring to my little chart that I drew down here. Now I can look at the table to help me find my answer. So this is going to be 1/2 times 0.5. F of 0 is 3. F of 0.5 is 3 times 2 is 6. F of 1 is 5 times 2 is 10. F of 1.5 is 8 times 2 is 16. F of 2 is 13 times 2 is 26. So then if I calculate that all out, I should end up getting 12 as an answer. So hopefully now you can use the trapezoidal rule to find the integral of a region.